DFS of two states with designated starting state over sigma is equal to a comma b comma c is option A 32, option B 16, option C 256, D is 128. So we need to find out total number of DFS with the possible strings over sigma is equal to a comma b comma c. There are number of inputs are 3. We can have 2 power 3 combinations, but if you use two states we can have a maximum number of 2 power 3 number of DFS, that is 2 power 8 256 DFS are possible. C is right option.
Be DCFL and L2 be another DCFL, then L1 intersection L2 is option A regular, option B DCFG, option C CFG, and option D none of these. Here if both L1 and L2 are DCFLs, deterministic context free languages, then their intersection need not be DCFGs. The DCFGs and CFGs are not closed under intersection. So L1 intersection L2 is context sensitive language but not CFG or DCFG. So your correct option is option D.
The number of NOR gates used to implement exclusive OR is 4, 5, 3 and 6. So exclusive OR means, for example, if A and B are the inputs, okay, so A exclusive OR B can be represented like this. It is A dash B plus A B dash. We used to get like this. Output is equal to 1 if both inputs are different. So this we have to realize using NOR gates. How many minimum number of NOR gates are required? We can do like this. A, B are the inputs you are taking. So A, this is one input. Next B, this is another input. Okay. So you take one more NOR gate from A and B like this. This is NOR gate. So this we are given as input for both of these. Okay, so we used to get like this. So now here this is A, B, so A plus B whole dash. Here we get A plus B whole dash. This is A. Here A plus B whole dash A. So this is B. Okay. So these two will be given for another NOR gate. So here this is given two inputs for this NOR gate. So this provides exclusive OR. By this time here you will get exclusive NOR. But when you again complement it, you will get the exclusive OR. So 1, 2, 3, 4, 5, minimum 5 are required. B is the right answer.
For the given graph, in which of the following order the nodes will be visited in BFS? Here a graph is given, and if you follow BFS, that is breadth first search, what will be the order of the nodes in which they are visited? This is a question. So if we start at vertex A, in BFS we visit the nodes in level by level order. We follow level by level order while visiting the nodes in breadth first search. So if we start at vertex A, at node A will be visited, and the nodes present in the next level are B, C, D. So we'll visit B, C, D, and the nodes in the next level are E, F. So after B, C, D, we will visit nodes E, F. So A, B, C, D, E, F is the BFS order. So correct option is option A. The following program fragment results in void. Here in this question, a C program is given and we have to find the output of the given C program. Here the program is void main. Here I is declared as integer variable and it is initialized to 7. If I is equal to 7, here I is compared with 7. If it is 7, then return statement is executed. If it is not 7, then else part will be executed. In else part, I is 7 is printed and after that end is printed. So here as I is initialized to 7, here if condition will be satisfied, and if it is satisfied, just return statement is executed. That means return statement just terminates the execution of the function. So here just here execution will be terminated without printing anything. It will not go into else part as I is 7. So here option D, that is execution termination without printing anything, is the correct option. How many minimal spanning trees are possible? Minimal spanning trees are possible on cycle graph with 5 vertices. Let us draw cycle graph with 5 vertices. So this is a cycle graph with 5 vertices, and number of spanning trees would be, if you delete this edge, you'll get one spanning tree. If you delete this edge, you get one spanning tree. This edge, for each and every deletion of one edge, you'll be getting one spanning tree. So the number of spanning trees would be C. That is 5, which is option C.
Shown in the figure below implements option A, exclusive OR gate, exclusive NOR gate, NOR gate, and AND gate. So in this figure, we are having C is input, is a selection line. So when C is 0, B bar will be selected. When C is 1, 0 will be selected. That means it will be C bar, B bar plus C into 0. So this will become C bar, B bar. So whenever C bar, B bar is 1, for example, C bar, B bar is 0, then it will become 0 will be selected. It will term become 0. Okay, then C bar, B bar is 1, it will select the A bar. So this will become 0 plus C bar, B bar, A bar. Okay, this is equal to C bar, B bar, A bar. That is nothing but A plus B plus C whole bar. A plus B plus whole bar means A bar, B bar, C bar, like that. So this is nothing but not R. So this is not R, NOR gate. C is right answer.
Which of the following is incorrect? Option A, LLK grammar has to be CFG. Option B, LLK grammar has to be unambiguous. Option C, there are LLK grammars that are not CFG. And option D, LLK grammars cannot have left recursive non-terminals. Here we have to identify the false statement. If you see option D, LLK grammars cannot have left recursive non-terminals. This is true. For the grammar to be LL grammar, it has to be free from left recursion. So in LLK grammars, we can never ever find left recursive non-terminals. So option D is true. Option C, there are LLK grammars that are not CFG. Here all the LLK grammars are CFG, context free grammars. So this is false. Option C is false. Option B, LLK grammar has to be unambiguous. Even this is also true. All the LLK grammars are unambiguous and free from left recursion. And option A, LLK grammar has to be CFG. Even this is also true. So here correct option is option C. Option C is correct.
Following is correct URL format. Protocol :/host/port or path, and these 4 options are given. So normally URL means this is a universal resource locator. The correct format is we need to mention the protocol like HTTP or FTP, whatever it is. Then :/ the host name, that is whatever the host you need to find out, like something like gateforum.com, something like that. Okay, again port number. So within that particular site, what is the port you want? That is a process ID. So the path will be mentioned. So option A is right option here.